Subterranean giants, the ghost in the granite. What if the mountains we climb aren't made of dead stone? What if every summit selfie, every triumphant flag planted into the earth, rests on something that is not geological, but biological? In February 2026, a multinational research team conducting deep penetration radar surveys across sections of the Himalayas and the Andes recorded something they weren't prepared to explain. The mission was routine, mapping tectonic stress lines, identifying hidden fault structures, and refining seismic prediction models. Instead, they found rhythm. Not random vibration. Not plate friction. Not microfractures releasing stress. Rhythm. A pattern pulsing miles beneath granite peaks. The February 2026 survey. The survey focused on remote sectors near the upper reaches of the Himalayan arc and isolated Andean ridgelines, regions where crustal thickness exceeds 70 kilometers. Using next-generation ground-penetrating radar systems, researchers transmitted ultra-low-frequency pulses designed to penetrate deep lithospheric layers. The goal was simple: visualize voids, density shifts, and fault anomalies. What came back was anything but simple. Instead of chaotic geological fractures, the scans revealed enormous, curved cavities embedded within solid granite. These weren't angular or jagged like natural tectonic fissures. They were smooth, continuous, symmetrical in places, vast. Some stretched for kilometers. Others appeared segmented, like layered structures wrapped around a central mass. At first, technicians assumed instrument error. A glitch in signal return. A resonance distortion from mineral composition. Equipment interference from metallic ore veins. So they recalibrated. They changed frequency bands. They switched antenna arrays. They cross-verified with secondary radar platforms. The shapes remained. The silhouettes beneath stone high-definition radar imaging revealed outlines that defied geological expectation. Within granite peaks, rock formations believed to be among the most stable and inert structures on Earth, were cavities resembling organic morphology. Not geometric. Not crystalline. Not tectonic. Organic. The voids curved inward like rib cages. Some regions displayed branching networks reminiscent of vascular systems. One particularly striking scan revealed a central mass approximately 3.2 kilometers in length, surrounded by layered concentric formations. Geologists struggled to classify it. It was not magma. Not a lava chamber. Not sedimentary intrusion. And yet, it was there, clear across multiple spectral imaging layers. The seismic pulse. The real turning point came when researchers compared radar imaging with archived seismic data from the same regions. Hidden within decades of microseismic recordings were faint, repeating oscillations. Every 26 minutes in one Himalayan sector. Every 18 minutes in a remote Andean zone. The pulses were too regular to be random. Too slow to be standard tectonic activity. Too deep to be surface interference. They resembled something else. A biological rhythm. When converted into audio frequencies, the waveform resembled a slow, powerful thud, followed by a long pause. Then another. Not identical. Not mechanical. Slightly variable. Like a heartbeat. The glitch theory. The scientific community reacted cautiously. Initial statements described the findings as complex subsurface density anomalies. Researchers emphasized mineral resonance effects and crustal pressure dynamics. Privately, however, some team members admitted the formations did not resemble anything in known geological catalogs. The glitch theory proposed that ultra-dense mineral veins were reflecting radar in unusual patterns, creating false organic silhouettes. To test this, the team expanded their scans across different continental regions. If it was mineral distortion, similar formations should appear randomly elsewhere. They didn't. The anomalies were isolated to high-altitude mountain ranges formed by massive continental collisions, regions where tectonic plates had fused with immense compressive force. It was as if something had formed alongside the mountains, or within them. The lithosphere question mountains are born through violent geological upheaval. Plates collide. Crust buckles. Stone rises skyward over millions of years. But what if something else was caught in that process? Or what if something adapted to it? The idea sounds impossible, that massive organisms could exist fused with tectonic structures. But extremophiles already thrive in environments once thought uninhabitable: deep sea vents, radioactive waste sites, polar ice sheets. Life finds pathways. But this would not be microbial life. The scale is staggering. The largest silhouette mapped so far spans an area larger than Manhattan. Its internal structure suggests segmentation, repeated structural arcs separated by dense, core regions. If these are organisms, they are unlike anything catalogued. They would not walk. They would not breathe air. They would not move in ways we recognize. Their metabolism, if they possess one, would operate on geological timescales. Minutes might be seconds. Centuries might be moments. Between mountain and beast. One of the most compelling hypotheses proposes a radical reinterpretation: these are not organisms inside mountains. They are mountains. Or rather, mountains are the mineralized exterior of something ancient, something that integrated with lithospheric matter millions of years ago. The radar pulses suggest expansion and contraction cycles measured in millimeters, barely perceptible, but measurable. Satellite interferometry has detected slight surface elevation shifts in areas corresponding to deep anomalies. Not tectonic drift. Localized inflation. Then deflation. So subtle that without precise instruments, it would go unnoticed. The Andean conformation. When the Andean scans returned nearly identical structures thousands of kilometers away from the Himalayas, the coincidence became impossible to ignore. Two different continents. Two different tectonic systems. Same type of silhouette. Same rhythmic seismic pulse. Different timing, but same pattern. Independent teams confirmed the findings using alternative imaging technologies, including magnetotelluric surveys and deep gravitational mapping. Each method revealed mass density distributions inconsistent with standard geological layering. Something massive is embedded deep within these ranges. Something shaped. Something structured. A hidden, breathing world? If these formations represent life, they challenge everything we understand about biology. Carbon-based organisms dependent on sunlight would be impossible at such depths. But life need not follow surface rules. Imagine a silicon-carbon hybrid biochemistry. Imagine organisms feeding on geothermal gradients. Imagine consciousness operating on tectonic time. Perhaps these entities are not creatures, as we imagine them. Perhaps they are planetary symbiotes, ancient biological structures intertwined with Earth's crust. Perhaps they stabilize tectonic pressure. Perhaps they regulate heat flow. Perhaps their pulses are part of a deeper planetary system we barely comprehend. Or perhaps they are dormant, waiting. The silence from above official reports remain cautious. Public summaries describe complex lithospheric anomalies requiring further study, but the raw data exists. The images exist. The pulses exist. And for the first time in modern geophysical history, scientists are confronting a possibility once confined to myth, that the mountains are not silent. That beneath the granite and ice, something vast and slow is moving. Not with footsteps, but with rhythm. A rhythm buried miles beneath our boots. So the next time you stand atop a summit, wind tearing across your face, stone solid beneath your feet, consider this: what if that stone isn't dead? What if the mountain isn't something you conquered, but something that allowed you to stand there? And deep below, far beyond the reach of drills and dynamite, something ancient pulses once more. Slow. Patient. Alive. Please like, subscribe and follow for more.